All right. Okay, so I sent you an email last night with some information, some links, and I just want to walk you through what we're going to be, how we're going to be sharing files and information in this course. So this is my lab website. I shared with you a link for it. This is the homepage, so it has a whole bunch of different things, where one of the tabs on top is called teaching. So if you click on that tab, there's going to be a couple of links here. So I'm teaching 2 courses this semester. One is the Advanced Topics in Precision Ag, the one that you're sitting in right now. The next one is Data Science and Statistical Programming Applied to Ag. Of course, for this course, you would click on that 2024 Advanced Topics in Precision Ag, and this will bring in the page for this course. Right, so here I'm going to have a lot of different links that you're going to be able to use throughout the course. And this is going to be the main resource that you're going to come looking for recordings, information, code, anything like that. So just to familiarize you, again, this is the Advanced Topics in Precision Ag course material. There is a schedule here where you can see the topics we're going to be covering each day. And as I have slides or code or class recordings, I'm going to make those links available here so you can follow up on them as well. Also on this page, so if you scroll down past the schedule, there's going to be the syllabus. There's a lot of information here on the syllabus. I'm not going to go through it right now, but we're going to be going through that in a presentation here shortly. So just wanted to familiarize you with the website for the class. Okay, so if we come here to the schedule, you can see that for today, it's basically just welcome and introduction. So I just want to get you familiarized and also learn a little bit about yourselves. Here you see that the link for the slides is active. So if you click on that, it's going to open this presentation as HTML on your side. If you want to just follow through with me here, you can do that. But also, if you want to refer back to this presentation, you can always go back to that link and follow along as well. All right, so I just want to walk you through here this presentation and just talking about the syllabus, what we expect, and things like that. So again, my name is Leonardo Bastos. I'm an assistant professor of integrated precision ag here in Athens. My office is in Miller Plant Sciences. So if you ever need to reach me, you're welcome to come to my office. It's on 4101, so 4th floor on that corner, the corner closest to Carlton Street. You can also email me if you have any questions. And I'm always available, and I'm always always want to make sure that you're understanding what we're doing, that you're learning. So very accessible, and you can reach me either in person or by email. All right, so let's just touch on some of the most important points of the syllabus. I want to make you all aware. It's going to be very important for us to set the tone for the rest of the semester. So we are meeting. Our lectures are Monday and Friday, 9:10 to 10, just like we're here today. Our labs are Wednesday from 9:10 to 11:10. And just a quick note on that. So really, we're always going to meet in the computer labs. And the reason for that is I'm not going to be giving you necessarily lectures and labs with that distinction. We're going to be live coding for most of this course, regardless if it is a lecture or a lab session. So just so you're aware of that. As far as location, for those of you here in Athens, you already made it to the right room, so you know where it is. So 1203 Miller. For those in Tifton, it's going to be at 601 Nespal South or remote. And for those in Griffin, it's going to be in person at SLC UGA Computer Lab or remote. And if you are attending remotely, I'm not going to share the Zoom credentials on the website. So it's going to be either on ELC or by email, since we don't want to spread those publicly. And I just want to take one step back here and just mention that, you see, and we're going to talk more about the attendance, but for those in Athens, you are expected to attend in person. If you have an issue that you cannot make it to class, or if you're sick or whatever reason it is that you cannot make it to class, please let me know before the class period. I would be glad to excuse you from attending that class without it being signal or considered a missed class. But for those in Athens, you are expected to attend in person. For those in Tiffin and Griffin, even though you do have your in-person locations, but you also have the option to attend remote. And that's just because since I'm not there, we give you that option as well. But you're, most certainly encouraged to attend in person. Okay, so let's just go through some of these course objectives and what you're going to be learning, what you're going to be getting from this course this semester. So number one is to obtain, process, and use various agricultural geospatial data layers for decision-making related to precision agriculture. So this, for example, includes, in this case here, I'm just showing you on the left is a raw yield monitor data for cotton from a field here in Georgia that we're going to be seeing a lot of this. We're going to be working with a lot of data from this field. And on the right, we just have elevation for that same field. So we're going to learn how to, if this data is open, if it's public data, we're going to be learning how to access open data. If it is proprietary data like yield monitor, you're going to be learning from some examples that we have on how to process it as well. Second objective here would be to expose you to different data types in precision ag. And this, precision ag we're saying here is mostly field level agriculture, right? So we're not talking about animal precision ag. We're not talking about controlled environment precision ag. This is field precision ag, where some of the data types that you're going to be exposed to include weather, soils, satellite remote sensing, as well as drone remote sensing, yield monitor data, and gridded soil samples as well. So these are all layers that you commonly are going to find if you're working in precision ag, regardless if you are in grad school, if you're going to grad school, or if you are not going to grad school, but if you want to work in a company that does precision ag work, you will be running into these layers of data on a daily basis. And so knowing, how to handle them, how to process them, how to learn from them is what some of the goals of this class are related to that. And here is just a few examples of some of the data types. So on the far left here, we have green NDVI maximum value on a pixel basis for this field. So this green NDVI, if you have not heard of it, is just a vegetation index that relates to crop vigor. So here we're just trying to understand crop vigor patterns in a field and relate that to anything else like yield or profit or different things. In the middle here, we have interpolated yield data. So here is data that has been already cleaned and interpolated. So it would be like one of the products that you're going to be learning how to do in this course. And then on the far right, we have soil electroconductivity, which is also a very common layer that you're going to find in precision ag research and industry. So we're also going to be working with that type of data. As a third objective here, we're going to be taking in this data, cleaning it, processing it, creating some knowledge from it. So this knowledge comes down through some of the different analysis we're going to be using on this data. So we're going to learn how to do zone-based and imagery-based variable rate prescription, how to create profitability maps, and using satellite remote sensing for crop scouting. So here's just an example, a few examples of that. So for the same field here on the far left, we have a UAN, a nitrogen fertilizer rate varying spatially in this field. So we have two rates there. It's not a very complex variable rate map, but it is a variable rate map nonetheless. In the middle, we have a profit map. So understanding, whenever we have our inputs are changing in space, our output or yield is changing in space, we can create spatially variable profitability maps and really learn what parts of the field a grower is making money, is cutting even, or even losing money. And on the far right here, we just have a animation for greening DVI of a field. This is a field, I mean, all of these fields are fields in Georgia, but the one on the far right is a field where the grower was encountering some issues with nematodes. So we pulled satellite imagery, trying to understand at what point of the season could we really see that signal from the nematode, and if we could have done something differently, either during that season or for the seasons to come, based on this geospatial knowledge that we're gathering. The fourth objective here is to do all this, all that you're hearing and seeing on these examples, utilizing the R statistical language. If you have never used R before, that's completely fine. I do not expect you to come with R knowledge. We're going to go very slowly, especially in the beginning, so you get acquainted with R and how we're using it for research. And really the reason why we're using R, so using a programming language, R is one option. Other people may utilize Python or different languages. But one of the main reasons here is to create modern, well-documented, and reproducible analytical workflows. What do I mean by that? So imagine that, in the future, maybe after grad school, maybe after your undergrad, you decide to go open your own consulting job and in precision ag. And then you start offering these different products. Well, I can create you a recommendation based on your monitor data. I can go and run a various for soil electric conductivity and give you a prescription for whatever it is. So you have all these processes, and imagine now that you start off with maybe a couple of clients, but then you start off, growing your business, and then all of a sudden you have 100 sites or fields that you have to take care of. Doing all this by using point and click software is, number one, very time consuming, and number two, very much so prone to error, right? If you've ever done a repetitive task using point and click software, I would imagine you know how easy it is to maybe select the wrong input, maybe name it a little bit differently, maybe select a different argument within, QGIS or ArcGIS, any tools within those software that you don't even realize, and then you create something that you made a mistake and you don't even know. So by using a statistical programming language, everything we're doing is already being documented with the code. So if anytime you want to redo that, or you want to make sure, oh, let me check what parameters did I use for this interpolation here, you can always go back to the code, and the code is going to be the record of what you did. So that's more on the avoiding errors. But then if you think about it, if you're doing the same type of analysis over and over for multiple fields, you can create basically the code one time and then just recycle it every time after that. So this is also part of it. Is the goal here is to get you used to, if you're not yet, to using statistical programming languages to do a lot of this processing and knowledge creation that we're going to be using in precision ag in a way that it is reproducible, that if you need to redo this a month from now, you can come back to it, run that code, it's going to run the same way. And you know exactly what you did because the code is a record of your steps. So here's just, you may be familiar with these already or maybe not, but R is the programming language itself. I don't think I know anyone that uses R by itself. Most people use some type of integrated development environment, IDE, like RStudio. So RStudio is just an easier way to work with R and to make things more fluid, that we're going to be using R in RStudio here. And then within R and in RStudio, we have a whole bunch of different packages that we're going to be using. On my course, every time possible, we're going to be using packages from the tidyverse family of packages. If you have not heard about this, I just want to quickly tell you what that means and why we're using it. So pretty much in any programming language, especially open source programming language that anyone can come and contribute to it, it's very easy that, perhaps I decide to write a package to interpolate point data. And then perhaps one of you decide to also create a similar package, but using a different concepts, different naming nomenclatures, or naming conventions, and so on. So what ends up happening in every programming language is that there is a few different packages that do the same thing, but all in a slightly different way. What the tidyverse is a family of packages developed mostly by our studio researchers that follow a similar framework and concept and philosophy. So they all kind of look similar, even though they're doing different things. And that just makes it easier for you to learn what they're doing, how to use them, and so on. So in my course, we're going to be using mostly tidyverse packages. You don't even have to worry much about that right now, but I just want to let you know in case you're already familiar with that. And then SF is a package to work with vector geospatial data, like polygons, points, and lines. So this is basically a workflow of something we're going to be doing this semester. So we're starting off on the top here with unclean EO data. As you're going to learn in this semester, unclean EO data potentially has many erroneous data points that we want to remove and clean before we actually use that layer for decision making. So we need to clean that layer, which you see on the map right next to it. And then one of the analysis we're going to be doing is spatial temporal yield stability. So the concept of that, just quickly to tell you here so you kind of understand, is that if you think of the same part of your field, if you have one field, the same part of this field, you're 1 year, the next year, and so on, that part of the field may always consistently produce high yields, or may always consistently produce low yields, or maybe it is unstable, it is inconsistent, meaning that this year it was one of the highest yielding parts, next year was it's going to be one of the lowest yielding parts. So this spatial temporal stability analysis allows us to understand that and to use that information to create recommendations. So we're also going to be using that approach. And then on the bottom here, we have elevation is the first map. It's kind of small, it's hard to see, but it is elevation. And then we have slope and aspect. So those are all terrain properties that relate mostly with water movement and also soil type a lot of times. And then we have soil electroconductivity that relates to soil texture, and everything the soil texture relates back as far as nutrient and water holding capacity. So then we're basically using all these secondary variables, so elevation and all of its derived variables and also soil electroconductivity to create zones that we then relate that back to yield and decide a variable rate amount. So this workflow here is a very common workflow that you would have in your research or even in industry as you work with precision ag. And we're going to be doing this in this course. One of the things we're going to be doing is this in this course. Okay, so with all that, I just wanted to have here some of the topics that we're going to be going through this course. So we're going to start with intro to R, and then using R as a geographic information system, accessing publicly available geospatial data through R, creating grids for soil sampling, doing interpolation, processing EO monitor data, processing terrain data, so having elevation and then deriving aspect and slope and so on, and other variables from that elevation data, create management zones, use UAV remote sensing data to create variable rate nitrogen application maps, working with profitability maps, and then using satellite remote sensing for crop scouting. So I hope that as you look at these topics, you can identify how this can either be useful in your research if you're in grad school, or even if you're doing research as an undergrad, or how learning how to do these in a reproducible manner can be helpful for your career. You know, if you're going back in farming with your family, or if you're going to work in industry with precision ag. Okay, so all classes will be recorded. And I have a YouTube channel that I post all the class recordings there. So if you do end up missing a class, you will always have the chance to watch the recording. So you're not going to miss anything. And I just want to again emphasize that this is more of a supporting tool for you to use when you either have to miss a class, or maybe you were in class but something wasn't clear and you think you want to go through that explanation again. but recordings do not replace in-person or remote attendance. And I just want to make this very clear. So we're all on the same page on that. Okay, so assessment and grading. So we're gonna have, this course is gonna have multiple different ways that you're gonna be graded on. And I think that was very helpful last semester, and I wanna keep that again. So 10% of our grade is gonna be a mini project that we're gonna be using United States Department of Ag NAS data. So this is gonna be data at the county level for different crop related variables like planted area, harvested area, yield, production, and so on. We're going to have a midterm exam that's also going to be worth 10%. We're going to have homework assignments, 35% of a grade, in-class quizzes of 15%. Something that I just want to make clear here as well. So the in-class quizzes, as the name says, it is going to be in class. And the only tricky part of that is if you're not in class, you cannot make up for it. Everything else you can make up for it if you have a good reason, and we can always talk about it. But the quizzes you cannot make up for it, and they're also not announced, right? So we're talking about something. I'll give you a very simple quiz, and that's how it works. And then we're going to have a final project that is basically going to. I'm going to give you a different data set, and you're going to redo all the steps we did during the semester to go from raw data to zone-based variable rate prescription. And then lastly, class participation, 10%. So this is going to be very important as well. It is 10% of a grade. I will be throughout the semester calling different people out to help me in class, ask someone a question. So you are expected to participate in class. So these are, just want to show you, these are links. So if you come on that presentation on my website, you can actually click on these links. So the course website is what I showed you earlier. There's going to be a GitHub repository. If you're not familiar with GitHub, GitHub is just a tool that we use to collaborate and share code, especially. We're not going to be making extensive use of GitHub, so that's not going to be a topic that I really want you to learn. If you already know how to use it, you're welcome to use as you wish, but I'm going to be distributing all of the data and code through GitHub, and we're going to get to that in a moment here. And then also the course YouTube channel, which is where I'm going to post the videos that you can watch later. So my slides, some of them are PDF, but some of them are HTML, like the one I'm showing you right here. So I just have some instructions here for you to, if you want to download this HTML as a PDF, so you can take notes on your computer. These are just some instructions for you to do that. I'm not gonna go through that, but you can just follow these and that would work. Okay, so as we are gonna see, I think maybe today, but so we're going to be using, again, GitHub for me to send you the code and the data that we're going to be using in class and also in your assignments. And GitHub has an issues tab, and I'll show you that in a second here. That it's kind of like a forum, right? So if you're familiar with any forum online that you go and post a question, somebody can come and answer. That's what issues is on GitHub. I will really encourage you to, if you have technical questions, that you send me by email. Instead of sending me technical questions by email, I want to ask you all to actually ask your question on the GitHub page of our course under the Issues tab. The reason for that is that I found a lot of times you may have a question that actually more people are also struggling with. So if you ask that on GitHub on our course page, you give other people the chance to also chime in, maybe help you that way. And that is also part of participation. So I know that some people may not feel very prone to speaking in class. If you don't like speaking in class, that's okay. You don't have to be asking me questions all the time. However, you have this option also of helping others, asking your questions, but also answering questions if you can on GitHub. So that's also counted as participation, and I do encourage you all to use that when you have questions, but also to help others that have questions and post there. So this is just some instructions on how you would create a new issue. I can just actually show you that here as well. So I'm gonna go on the GitHub for this class. Just want to show you that. So as you come here, I have some text here just to say what this is. And then we have on top here, we have this issues. So if you come here on issue and you click on new issue, we can just say, I don't know, help with interpolation, whatever it is. And then you can explain what you're going through. It's normally useful to include either the code itself or a screenshot of your code and your error, so other people can help you with that. So this would be issues on GitHub. So now if I come here on issues, I see there's one open issue. I can come here and comment as well. All right. So let's actually try it out. So what I want to do is I'm gonna come here to the GitHub repo. So if you're here in Athens, this is the address that you would go through. So it's github.com/Leo M. Bastos. That's my page. And then within my page, there is the repository of this class that is 2024_PPA. That stands for Programming Precision Ag. So if you want to go there, I want to open an issue here and call this introductions. So I want you to enter your name, your department, if you are a PhD, master's, or undergrad. So I am professor, instructor, in your campus. So I just created this issue. So please go ahead and let me actually, for those of you online, let me paste this in our chat here. And this is also, just so we know, this is also going to count. Well, sorry, if you don't have a GitHub account yet, please go ahead and sign up for that. It doesn't take a lot of time. And we're going to be using a lot of GitHub this semester, so that's going to be worthwhile. And so, and just to let you know, this is also going to serve as your attendance for today. I'm going to be taking attendance on GitHub on different ways. So today, the introduction is going to be the attendance for today's class. Just going to give it here a couple of minutes. And for those that are not in Athens, if you have any issues, please feel free to open your mic and speak up, or write in the chat, and I can help you out.
Hello. How do I verify my account?
Sorry, can you repeat that?
How can I verify my account? I'm just trying to do that and it is not working.
Hmm. So how to verify your account? Let me check. Is anyone else having issues verifying your account? Because I've signed up for GitHub a while ago and I don't remember running to that issue. Um,
Sent an code to your email.
okay. So have you checked your email, the email you used to sign
Yeah.
up?
Yeah, I'm checking it. There is no email yet.
Hmm. Not on your spam folder?
Let me check my spam. No, no spam either. Can I share my screen to show that?
Sure. Yeah. Let me
Okay.
stop sharing mine.
Yeah, share screen. It
Oh,
is still not working.
let me give you,
Yeah, permission to do
yeah.
that.
Okay. So you should be able to share now.
Yeah, I think. Is
Are you,
this a, is this visible?
yes, yes, now it is.
Okay. So in my Zoom, yeah, this is what I'm saying.
Have you clicked on verify your account?
Yeah, I can't click on it.
Receive. What if you keep scrolling down? Does it have a
Yeah,
number? No, it has nothing there. Hmm, interesting.
should I use my UGA email ID instead?
It shouldn't make a difference.
Yeah.
Yeah, I'm not sure. Has anyone else? So for those here in Athens, did anyone see the screen and not be able to pass through it? No. Yeah, I'm not sure, but we can connect after class and I can
Okay.
we can try
So
it.
I can't get verify. It keeps saying that that's not right. And I keep rotating and it's not, it keeps saying that it's not correct.
So you're also not able to sign up, Rolando?
No, I mean, I'm trying to verify
Mm-hmm.
and when I rotate the image in direction of the hand,
Mm-hmm.
it keeps saying that it's, well, when I do it 3 times, because it's asking you 3 times, it doesn't do anything. Do you want me to share
So
so
let's
you
do
can see
this.
it?
If well, is anyone so besides Rolando and Kumar, is anyone else having issues to sign up? Okay, here in Athens, I don't hear anything. Okay, so maybe let's connect just the three of us, or if anyone else has issues after the class, and then we can walk through that and see what's going on.
Sure.
All right, let me share again. Okay, so if you were able to already introduce yourself on GitHub, that's great. If you were not, you know, we can look into what's going on with your we're signing up for GitHub. Okay, well, this is just something that I said earlier, that if you helping others on GitHub, it also counts as participation. So keep that in mind. So this is just our attendance policy. We already talked about it. So if you're in Athens, you must attend in person. If you cannot, due to special circumstance, please let me know before the class. If it is something that I mean, sometimes you may have to go to the field or just something like that. You can let me know, and that's completely fine. And And if you're ill or something, you know, just let me know as well. And I'm very flexible with that. And again, students from Tifton and Griffin, if you wish, you can attend via Zoom, but you also have a place to attend in person as well. And this is just just to inform you. So if you miss more than 5 class periods unexcused, I reserve the right to drop you from the class. I never had this happen. I hope this doesn't happen to any of you. And of course, we actually plan to not get to that point. If you have to miss classes for different reasons, again, come talk to me before that class period and we can accommodate that. But make sure that if you do miss classes that are unexcused because you didn't let me know beforehand, then your cap is 5 class periods. And again, if you're attending online, please have your cameras on at all times. These are just some technology and software requirements. So you will need a computer. If you have your personal computer, your personal laptop, I would encourage you to use that because some of the things we're going to be using and installing are things that I hope you can take beyond this class and actually use for your research, your work, and so on. And you're also going to need a second screen. If you are attending in person, regardless of the campus, your second screen is going to be the screen right in front of you, the projector screen right in front of you. If you are attending from home or remotely, you will need to have a second screen because we're going to be doing a lot of live coding, meaning that you're going to have to be looking at me in one screen and then doing the coding on another screen. So you will need that. If you don't have a second screen on your remote location, you can always come in and attend the class in person at your campus. And if for some reason you cannot have the setup of having one computer and one second screen, let me know and we can look into potential accommodations for that. All right, so this is something kind of new that we didn't talk much about last time I taught this class, but now it's increasingly important. So artificial intelligence, LLMs, and plagiarism. What I'm going to tell here is, I know that if, using ChatGPT and other large language models, it can be very useful for coding. I do want to say that it's okay from my perspective if you want to use those resources to do the assignments of this class, as long as you use it to learn and not simply to copy and paste. So let's say you are trying your code, something's going wrong, you already Googled it, you cannot figure it out, you posted on issues on GitHub, nobody could help you. Then you use ChatGPT to how to do this or fix this code for me or something like that. As long as you learn what it did for you, I'm okay with that. The issue that I have that's actually not going to be something that I can assess is if you're simply copying and pasting. I will be able to assess this in our exams, right? Because part of our exams are going to be theoretical, parts are going to be coding. So if you learn something through chat, or if you did not learn something, but you just copy and pasted something from ChatGPT, you will not be able to complete the exam, right? So again, you can use these tools if you wish, you don't have to. But if you do use them, make sure that you're actually learning what's doing for you. Don't simply copy and paste. And also, if you're using it, give it appropriate credit. I don't care if you use it or not, as long as you're learning. So if you're learning, give it appropriate credit. You're not going to miss any points from my side because of that. And I just want to remind everyone that plagiarism, both from your classmates, but also from ChatGPT and other models like that, is a very serious violation of code of conduct, and I will report that if I pick that up. So let's just be clear, transparent, and we are all going to do just fine. Okay, so I do have a survey for you that I would like to ask you to fill that right now in class. So let me just open that on my side and I can paste this on the chat. So if you're following online, you can This is the link. If you're not following online, you can either, eyeball this and type on your browser, or maybe if you go to my website and you go to the class material, go to this lecture, you can click on this. This is a link that you can click. So this is just a survey for me to get to know you a little bit better and also understand your interest in this class, what you're trying to get out of it. And so I can use that information to tailor some of the content and cover what your interests are within the scope of the class. All right, I'll give you another minute here and then we'll keep going. All right, so I'm gonna keep moving here. If you have not finished yet, that's okay. You can just leave that window open and you can finish at the end of the class period. Please make sure to finish before the end of today. And that should be enough. So lastly, I just want to get you ready for next class. So next class we have is going to be on Wednesday, and we're going to be we're going to start with intro to R. And so if you're already familiar with R, this may be very basic, but I still, you know, I still ask you to complete the class and the exercises. If you've never used R, this is going to be your first encounter with R. So if you have any issues, please let me know before the class period so I can help you. But basically, if you come, let me come back on our class webpage. Teaching advanced topics in precision ag. So right in the beginning of our page, there is this lab 1 prep link that I want you to go through. So this is just, if you don't have yet, these are just some instructions for you to install R Studio, download the class material from GitHub, install packages, and well, sign up for a free GitHub account. You may have already done this, but you can just go through these steps here. It will walk you through on how to do all that. If something doesn't work, if something doesn't make sense, let me know. You know, we can either meet in person or like we can just a lot of times what I found is that, you know, if you're really stuck on something, especially in the beginning, since you're still developing your skills, if you don't know R yet, we can just jump into a Zoom call very quickly and I can just help you out that way, if I'm available. So yeah, so this would be the last part of today's class, is just for you to, and you don't have to do this now, but just please do this before next class, is to go through, excuse me, the intro to R prep and make sure to complete all the steps here. All right, so that's all I had for you. We're almost at the hour. Just want to, you know, before we just close, I just want to open up if anyone has any questions that I can help you with now. And Kumar and Rolando, I can help you guys afterwards for us to get the GitHub going. But before that, anyone has any questions for now? Yes.
Oh, I just said I was able to do it. I guess I was just pointing the angle wrong,
Okay.
but we got it now. Thank you.
Nice. Good deal. Any questions? Yes.
Do you have any preference for each OS?
Yeah, so let me just repeat that so everyone online can hear as well. So the question, sorry, what's her name? Renalisa. So Renalisa is asking if there's a difference to use R in Windows or Mac. I use on Mac and I found that, I mean, I guess a lot of people don't have the option. They normally have one or the other. So whatever one it is you use, it should work fine. I mean, a lot of people use Macs and a lot of people, I mean, it was a good split between Macs and PCs last semester or last year, and it was all right. If you do have the option, for some reason, I would say just use whichever one you feel more comfortable. I particularly prefer Macs. I think that it's not an R thing, but I think that for programming, a lot of times R is already better set up than Windows. So, but anyways, if you have Windows, you don't have to worry about it. You know, you may run into a few issues, but everything is solvable. So no worries at all. Yeah. Any other questions? Yes.
Do you have any office hours outside of the class?
I don't have fixed office hours. Normally like if you need something, you can email me. And if I am in the office, I mean, we can touch base right there, or maybe, you know, we can set up a Zoom call for some time that I'm available. Yeah, but I normally, I don't have fixed office hours. All right, any other questions? Okay, I'm not hearing anything, so I'm gonna call it a day. Kumar, do you still want some help with GitHub? Sorry, you're muted.
I'm trying to do it by myself. If I can do it, I guess it will be good. Otherwise, I'll need some help.
Okay. Yeah, if you need help, just
So-
email me. We can
Yeah, sure,
Zoom.
sure.
Yep.
I'll do that.
All right, sounds good.
Okay.
Thanks, everyone. See you on Wednesday.
Thank you.
Thank you.
Thank you.